Hello students, today we're going to look at the last part of section 10.2, which is still simplifying radicals, but this part is rationalizing the denominator, okay? Sometimes the numbers can just be irrational. Crazy. And you know it's crazy when you have a square root in the denominator. We don't like square roots in the denominator, and as a matter of fact, we can't have a square root in the denominator. So that's just an irrational thought to have a square root in the denominator. So in order to get rid of that irrational thought, we have to rationalize the denominator so there's no square root. And this is how we do it. We've got the square root of 35 over 15. Well, the first thing I want to do is simplify 35 over 15 because I want to put it in simplest form to make calculations easier. So what goes into 35 and 15? That would be 5. So then now I have the square root of 7 over 3. Okay? And you know from multiplication, it works the same way with the division. The square root of 7 over 3 is the same thing as the square root of 7 over the square root of 3. And here's where we have that irrational stuff going on. We've got a square root in the denominator, and we just can't have it. So I've got to rationalize it. To rationalize it means to multiply by 1. Ooh, shocker. If I multiply this by 1, then I haven't changed anything, but it's the form of 1 that is the trick. So in order to rationalize this puppy, I have got to multiply by 1, and to get that 1, I'm going to use the square root of 3. And so I'm going to multiply by the square root of 3 over the square root of 3. Because the square root of 3 over the square root of 3 is 1. Because anything divided by itself is 1. So all I'm doing is I'm taking the denominator, and I'm making it into 1, which is square root of 3 over square root of 3. So then when I multiply, the square root of 7 times the square root of 3 is the square root of 21. And then the square root of 3 times the square root of 3, here's the tricky part. That's actually the square root of 9, but what's the square root of 9? 3. So when you have a square root of a number times the square root of itself, the answer is just that number. So the square root of 3 times the square root of 3 is 3. The square root of 7 times the square root of 7 is 7. The square root of 15 times the square root of 15 is 15. The square root of 6,923 times the square root of 6,923 is 6,923. So what I've done is I just rationalized the denominator. So the square root of 35 over 15 actually simplifies to the square root of 21 over 3 because I got to get rid of the square root in the denominator. So the next example we're going to look at is the square root of 45 over 10. So again, 45 over 10 is not in simplest form, so I can divide both of those by 5, and I get the square root of 9 over 2. And now I can put that to the square root of 9 over the square root of 2. Well, we know that the square root of 9 is 3, so I'm just going to, simplify that even farther to make it the square 3 over the square root of 2. Because the square root of 9 is 3 and the square root of 2 is still the square root of 2. But here's where it's irrational. I cannot have a square root or a radical in the denominator, so I'm going to multiply by 1. What's my 1 going to look like? It's going to look like the square root of 2 over the square root of 2. And so 3 times the square root of 2 is just that. It's 3 times the square root of 2 over, what's the square root of 2 times the square root of 2? 2. So now I have 3 over 2, and those are both rational numbers. Those are both integers. Can I simplify 3 over 2? No, I can't do anything else to that, so I just leave it like it is, 3 times the square root of 2 over 2. So the square root of 45 over 10 simplifies to 3 times the square root of 2 over 2. So here are 2 more examples we're going to look at. The first one, letter A, is the square root of 32 over t to the 4th. Okay? I can't do anything else to simplify that, so I'm just going to see if I can figure out anything. Do I know what the square root of 32 is? Well, first of all, let's change it to the square root of 32 over the square root of t to the 4th. Do I know what the square root of 32 is? No, it's not a perfect square. Is there a perfect square factor of 32? Yes. And what is it? No, it's not 4. That's what you thought. It's 16. So I've got the square root of 16 times 2 over, what's the square root of t to the 4th? Well, that's t squared. So the denominator's done. There's no rationalizing anything because there's no radical in the denominator. So I've got the square root of 16 times 2, so that equals the square root of 16 is 4 times the square root of 2 over t squared, and I'm finished. Just simplified, there's nothing to do to rationalize because there's no square root in the denominator. So let's look at here. The square root of 3/16 times the square root of 9/5. Okay? Now, you're probably thinking to yourself, the square root of 16 is 4, square root of 9 is 3. What should I do? Go with it. So, first of all, we're going to make this equal the square root of 3 over the square root of 16 times the square root of 9 over the square root of 5. Okay? Now let's do what we can. So that's going to be the square root of 3 over 4 times 3 over the square root of 5. We good? Now let's multiply those. I'm going to swing around, and I'm going to come down here. So I've got 3 times the square root of 3 over 4 times the square root of 5. Ding, 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 ding. I've got a radical in the denominator. I can't deal with it, so I have to multiply by 1. Well, what's my 1 going to be? Square root of 5 over square root of 5. Exactly. Because the 4 is a whole number, it doesn't play into this yet. It will. So I'm going to multiply by 1, and that 1's going to look like the square root of 5 over the square root of 5. You with me? So now it's 3 times the square root of 3 times the square root of 5. Well, the 3 is just going to stay 3 because it's a whole number outside. But the square root of 3 times the square root of 5 is the square root of 15. Okay? And then the square root of 4 times the square, 4 times the square root of 5 times the square root of 5. Well, the square root of 5 times the square root of 5 is 5. And I multiply by the 4 that's already there. So 5 times 4 is 20. So the simplified version of the square root of 3/16 times the square root of 9/5 is 3 times the square root of 15 over 20. I can't simplify 3 and 20, so I just leave it like it is. If I could simplify 3 and 20, I would, but I can't. And here are your 3 practice problems. The first one is simplify the square root of 50 over 12. The second one is the square root of h to the third over 8. And the third one is the square root of 7 over 2 times the square root of 5 over 3. Work those out. Rationalize the denominator so there's no square roots in the denominator. Take a picture of your problems and turn it in via Edmodo.